Okay, cool.
All right, hello everyone. I am Kyle Zhang, and I thank everyone for being here and for joining. A little about me. I'm going to be a senior at Lake Oswego High School, and I'm very interested in computer science, just like everyone else here. So here is a little rundown of the format of the panel discussion. In the first half, I'll ask the professors. We have Dr. Fern and Dr. Zhao with us, with some common prepared questions. And in the latter half of the discussion, the professors will address your specific questions. Anytime, you are welcome to ask any questions or comments that you want in the Zoom chat. And as I mentioned, today we are very fortunate to have two professors with us in our discussions, taking time from their busy schedules to answer any of our dying questions. The professors we have today, Dr. Fern, Dr. Zhao, may you guys both introduce yourselves and give us one general advice to high school students who are thinking of majoring in computer science.
I can get started. Hi, everybody, and it's very exciting to be here. I don't really have a lot of experience actually interacting with high school students, except for outside lab settings. So this is kind of exciting, and especially this community, I was very happy to see there's this vibrant community of Asian, Chinese, and interesting computer science, and I think this is great. Really good job, Kyle. So a little bit about myself. As I said, my name is Charlie Fern. I'm a computer science professor at OSU, Oregon State University, and my area is in machine learning and artificial intelligence. So I've been doing machine learning, artificial intelligence since 2000. That's when I started my graduate degree. And I've seen lots of exciting developments in this area. And I think this is really a great time to jump in the wagon of computer science and study. I would say computer science is becoming one of the quintessential skills, besides math and language skills that you can communicate with people. I think computer science is becoming the third kind of leg for all possible future career development. So I think it's great you're thinking about computer science. My advice would be, don't think about it anymore, just do it. And it's really exciting era, and it's a lot of exciting developments, and the programs around many schools are very vibrant, and just kind of because it's such a fast developing field, and I think it's going to be really exciting.
Great. So my name is Xinghui Zhao. I'm a CS faculty in Washington State University, Vancouver. So I'm not so far from all of you, also in this region. And as Dr. Fern has said, I totally agree that computer science is a very promising field for young students. And if you're thinking about getting in this area, I think this is really the right time to do it. You see lots of different research areas and lots of very nice applications out of this field. And I'm sure that you have read a lot of computer science related articles, or you've seen video games and lots of these things that are really interesting. One advice that I would like to give you is, as a high schooler, when you get interested in some field, I guess one question that I want you to ask yourself is why you're interested in this, right? The answer, I hope, is not something like from outside. For example, my parents like me to do this, or I think this is the best area because lots of jobs are out there. So these can be the reasons, but I think just from inside yourself, like what is your passion? I think that is something to think about. As a high schooler, you're still early, in your career. You're looking for all these different areas, but like Dr. Ferns has said, it's really nice to see lots of high school students are interested in this field, and just ask yourself where your passion is. And even within computer science, there are lots of different fields, right? You can choose the one that you're really interested in, that can motivate you to continue in this career path. Very, very happy to meet everybody. And my area is in distributed systems, parallel computing, and I also do research in machine learning as well, mostly in applied machine learning, like data science, we deal with lots of different types of data. And yeah, that's a brief introduction, and I'm happy to answer any questions that you have.
Awesome. That's a very great point that you guys bring up, that we ourselves need to go out and start doing computer science, and we need to be powered by ourselves, not any external forces, just our own passion. That's a very good point. And that actually leads into my next question. How did you specifically get into CS and become a professor?
Should we do the same order or alternate?
Sure. Either way is fine. You can go first, Xiaoling.
Okay. So my route into computer science is actually a little bit different, because I did my undergraduate actually in the EE area, like in control. And for master's, I started going to pattern recognition and basically studying, interfacing kind of a machine learning with some of those control issues. And for my PhD, I started looking, really delve deeper into machine learning, and that becomes my focus. And when I looked for a job, and I think what I found, based on my understanding of myself, is that I like the freedom. I like a lot of freedom in my creativity. I want to be, I can get excited by something today, and I can just actually start thinking and working on it. And I don't have to get approved by other, my supervisor in the company. So that's the main reason I became a professor, because I think I really, really enjoyed academic freedom in terms of the type of problem that I can solve. And also it's a very intellectually stimulating environment when you are working as a faculty. And both in terms of your collaboration and also with the young minds that you work with when you are teaching and when you're working with students. So those are the kind of primary reason that I got into become a professor instead of working in the industry.
Yeah, I got similar answers here, although I did all my degrees in computer science, but I have the same reason why I wanted to go into the research and become a professor. It's because I can decide what I do. Like, I can create my projects, and I can choose, who to work with. I can work with industry, and collaborate on some very exciting topics. I can advise students and educate them, and see, they are getting in this field as well. In terms of why I got interested in this area at the beginning, I think that went back to my middle school age, just like you guys are a little younger than you guys. Back then, we have really old computers, like a very old school style programming language. I don't even know if you guys have heard, like BASIC, those type of programming language. But I really got interested in, the idea of communicating with a computer, right? So it's just like you communicate with another person and you use natural language, but for, asking a machine to do something that you want it to do, you need to learn the programming language. You need to learn the basics behind it. and how to send the instruction to that computer. And all those things just, made me really interested in learning all this stuff. And that's how I got interested in the field. And then I got my undergrad degree and then graduate degree, all of those, and also PhD, all of those are in computer science. And in terms of research area, like I mentioned before, I started with parallel computing and distributed systems because, that's like a traditional area, research area where you can just put it in a simple way. You can speed up your computation, right? You can utilize all the resources that are available, whether it's the cluster or like a large distributed system where you have lots of different devices, right? You have mobile phones, you have laptops, computers, you put them together and solve a problem collectively. And that's an interesting and exciting field. Even now, it's still, it's a growing field. And then from there, I got into several projects which involved machine learning, like dealing with data, real world data. I can go on and on for this, but the thing is, I would like to use the the technologies that I have learned in the past and solve real world problems. That's how I got into the machine learning and data science field. Just to end there, so we can take more questions.
Yeah. Okay, awesome. I feel like knowing your guys' stories helps us inspire and build our own paths for our own futures. So that's awesome. Yeah, so now I am going to dive into more of the more computer questions, I'd say. So yeah, we got to know your stories and what you guys do, so that's great. And then my next question is, what is the difference between computer science and computer engineering?
Wei, do you want to go first?
Sure, that's a great question. Actually, you see, lots of universities, they actually mix these two together, and there's like a difference. But I think now you see more and more, computer science engineering and computer science and engineering departments, right? So they actually mix those two disciplines together. So in my opinion, I think computer science, just from the name, right? Computer science more focused on science aspect. Like if you talk about courses like, things like algorithms, software engineering, like more on the software side. But computer engineering is, I think you have to know more the hardware aspect of it. For example, computer architecture, I know the real lower level things, but computer science, it's not, like the hardware aspect is not that obvious. So that's one, I think, difference that I can see. In terms of applications, there are different applications as well, right? But as I said, now you see like lots of places they actually mix these two together, and those two disciplines people work together as well. So I guess it's good that you want to know the difference, but moving forward, I see lots of good opportunities for these two disciplines to, for people in these two disciplines to work together and merge. So that's what I think.
Yeah, I agree with what Xinhui was saying. I think computer engineering is more on the kind of focus more on the hardware side, and computer science is more focused on the software and also the science side, theoretical understanding of programs and problems that computer science can solve. And So I want to also mention that a lot of computer engineering are actually in some schools are lumped with electrical engineering. So you would see departments like electrical and computer engineering. And that's also kind of a more traditional kind of progression, how things developed. And in those cases, I think you can see there's definitely connection between computer engineering with the electrical engineering, like circuit design and those type of things are definitely rooted in electrical engineering. And then when you actually apply those to the computer systems, and that becomes more of a computer engineering. And there's a lot of intersections. So you can think of computer science and then electrical engineering. That's computer engineering is kind of sitting in between. There's a lot of interactions. And I believe, so it depends on the school that you're thinking about applying. The computer engineering might sit inside computer science or might sit inside electrical engineering and computer engineering department. And for example, for Oregon State, we have an EECS combined program. So the distinctions between those programs, even though we have the distinction, but students, as you come in for a particular area, for example, you study computer science, you can still have a very strong system focus. You can do embedded systems, you can focus on computer architecture. I think like parallel computing, that type of thing is also a little bit more on the system side because it's trying to figure out how software and hardware can work together in a more cohesive and more efficient way and make the best use of the systems hardware. So yeah, it depends on the school that you're applying. There's those minute differences, but don't make that a breaking point for you because as Xinhui has said, this is very fluid. You can actually tailor your degree or your study focus toward the hardware side or the software side. So.
Awesome. All right, knowing that excellent information about computer engineering and computer science, their differences and how they cohesively relate, that leads to my next question. Could you name a few key fields in computer science? And that would potentially spark ideas for potential paths and interests for us.
I'll just go first. So there are several, depending on how you divide things, right? Some of the areas that we have already mentioned, right? You guys are all interested in AI and machine learning. That's definitely one area. And systems and networking. So that's another area which is more, closer to the hardware, right? Dealing with system issues and also the networking protocols and stuff like that. And on the other side, there's a software engineering field, which you basically focus on how to make a software and how, or the methodology behind software development, testing and be able to come up with nice requirements for the software and the design phase and the development and testing phase, all those, software development related topics will be in there. And other things like programming languages, right? A compiler. So that's another angle of this. So I'll let Dr. Fur to comment on the more hardware side of areas.
Yeah, so there's also, I think there is a few other things. There's also more kind of on the softer side, human-computer interaction. That's kind of study how human and computer work together, software system. How can you design a software system that best support humans' needs and how? So that's one of another kind of more related to psychology and social science side of things. I think some of those, for example, we have at OSU have this something called a gender mag that's trying to study the gender bias of software systems. And that's pretty kind of interesting area that is really focusing on how human and computer come together and the impact of the computer system on the humans. And there's also cybersecurity. I think that's a very, very critical area now, given how the ransomwares and all those hacks are increasingly frequent And we also live in this all connected world. So the cybersecurity becoming a really increasingly important, critical almost area to study. There's database systems and computer graphics and visualization, stuff like that. And so it's what did I say? Computer database system that's involving management of different source of data and how to actually maintain them and keep the provenance, meaning that you know which part comes from what, and having making sure that things don't get wiped out. So there's a lot of interesting also research in those areas as well. And computer graphics, if you're into video games, computer graphics is one of those areas that's pretty important to make your video game look real, and instead of having stick figures. And so, yeah, so I think that's just there's also different way of looking at computer science areas. Another way of thinking about it is how, what kind of application areas you want to work in. So computer science can help in a lot of scientific domains by providing computational tools and analysis tools, and AI and machine learning has a lot of application in that. So for example, bioinformatics is a lot of times actually considered as a sub area within computer science because it's really using computational tools and to analyze biological problems, study biological problems. Yeah, so that's a different way of looking at kind of how the areas actually develop. And
oh gosh, awesome. Dr. Zhao brought up AI and machine learning as the first field of computer science to come up to mind. And of course, it has a very bright future currently. Could you please give us a few potential AI breakthroughs for the near future, next 5 to 10 years?
It's a great question. I think one direction is for AI applications to be closer to the end of the cloud instead of running on the data centers. So that's basically the current trend, right? So before you see, you know, data mining and AI and machine learning applications, they're running on really large clusters and data centers, right? Because you need to mine the data. You need the computational power there. But with the field, you know, growing into a point where you have lots of diverse applications where you actually sense the environment, right? So you gather the data from sensors, cell phones, you got lots of different types of data sources. And you would really like to analyze the data on the fly at the end of the cloud, like at the edge of the cloud. That's what it's called, edge computing, right? So like when the computation will be running closer to your user, right? So wearable devices and stuff like that. So in that aspect, you really need to investigate how you can actually make the large amount of computation running on a resource constrained environment, like, you know, like some very small devices like Raspberry Pi, or now like Google has those edge AI boards, right? So like just a single board computer. That's a challenge, but that's something that I think this field will go into, like at least, you know, one direction, right? So that's one thing. Another thing is the energy consumption of doing all these large computations, and that is an area which attracted lots of attention as well. Now, one of the solution is to actually put the AI algorithms in the hardware level, right? So now you see like neuromorphic boards, things like that, to get the hardware to mimic what the brain does, right? So that gives you a really energy efficient solution. So those two things are what I think, you know, moving forward, people will focus on, right? One is to run these computations in the resource constrained environment. Another is try to move toward the energy efficiency for these applications.
So I think I was thinking when I was thinking about this problem, this question, it's a very interesting question, and I think you ask different researchers, you're going to get different answers. And for me, I'm thinking about the societal impact that AI and machine learning technology is going to bring. The things that I really feel very excited and then have high anticipation of is primarily focusing on the medical field. So I think one of the things I'm hoping within the next 5 or 10 years, we will be able to see product or at least something related in that realm is kind of artificial limb that can be controlled by brain. So using AI, using better sensing, using non-invasive technologies to actually collaboratively create this better brain and computer interface that allows you, for example, if you have an artificial limb, you can actually control it using your brain signal. So you have embedded devices in your head. So that's one of the things that I think Elon Musk at Neuralink, that's actually one of the things that they're trying to work on. They still have lots of challenges, and especially on the sensing side. But I think the technology is pushing toward that direction. I think it's gonna. I think there will be some breakthrough in that area. Another thing that is about kind of medical care and in terms of medical research, I think the big data era is going to change how medical research and breakthrough is going to come about. So we know, medical domain it's really plagued by all those small sample sizes. Like you have a study that if you can enroll, hundreds of patients or for example, a cancer study, it's very, very small sample size usually you deal with. And but as we actually start to collect more and more data with both the sensors that Xinhui was talking about, all those in-home sensors and you can wearables and all those different devices that can provide data monitoring individuals' health status, and then the collective availability of all those different data and together with machine learning, AI technology to actually integrate them and to actually try to solve some of those fundamental medical mysteries. And I think we're going to have a lot more breakthrough coming from that. So that's my two areas to look out for.
Awesome. I promise this might be one of the last questions about AI for a bit. Are there any potential dangers or concerns in the artificial intelligence area? And also with that said, are there any misconceptions about the dangers of artificial intelligence you would like to address as well?
I can go first on this one. So I think there is a lot of debate about artificial intelligence, the danger of it, but I think the type of singularity type of danger is definitely a myth. And I don't think we're going to achieve human level superintelligence that in our lifetime. It's really far away from that. And the artificial intelligence that we deal with are really very task specific intelligence, and you can't generalize. And there are people studying generalization, try to make things just to understand. For example, you can, we have a project here, it's called Machine Common Sense, meaning that we want to build systems that actually have common sense like humans do. Like if you have an object that's there and if you don't look at it for a while, assuming nothing happened and it's still going to be there. That's called object permanence. And that's one of those common sense that infants, like humans, develop very, very early on. And that type of thing, unless you explicitly code it into the program, it is very hard for computer science, like machine learning, to actually learn that type of common sense knowledge. And so that's a kind of example where, AI intelligence, they seem to do very, very smart things, but they are highly specialized. They're not really have the capability to learn very general knowledge and in that sense. So that's, I would say, kind of the singularity type of thing is really a myth, and not too concerned about that. You shouldn't be too worried about that. In terms of the danger, real danger, and so the way that I see it is AI is tool. It's a technology. It's a tool, and the danger really resides in how this tool is being used by the creators and the users. So one example probably will come closer to home is the the big companies, the big tech companies using AI to actually push the content to you. For example, giving you the right, serve you the right advertisement and give you the right news to watch. And so those things, a lot of behind, it's all AI. There's a lot of AI behind that, not very sophisticated, but very kind of it's fundamental part using machine learning, using AI. And the goal of that is primarily trying to increase click-through rate, right? Keep you hooked on the computer, keep clicking those links and one after another, keep you buying things. So it really creates this type of usage of the technology it's very, very dangerous, and it's unprecedented. We don't know how they're going to impact humans' ability to actually focus and their attention, and all those aspects are not studied, and the companies are really profit driven. So I think that's a big danger, and I hope if you guys work on going into computer science, working in this kind of area, and when you choose your career path, and hope you think about those consequences more carefully and not really just go into the blindly profit chasing career and then really become part of that machine. So that's my warning.
Great. That's really well said. I agree with what Xiaoli has said, and just a couple of things to add to that. One common concern that I always hear from people about using machine learning and AI to deal with lots of things, and they worry about losing jobs, like regular human being will be replaced by these machines because we don't need that much manual power anymore. So that's one worry that I always hear. But I think for you guys as future engineers or scientists, this is really not something that you should worry about, because like Xiaoli has said, right? So AI is a tool, and we use this tool, and the tool will help us, right? If you put it in a way, it doesn't take things away from us, but it opens up more opportunities for us, right? So if we don't have to make this group of people to work on those simple tasks, instead we use machines to do that, and then this group of people can do something else that we have never imagined before, right? So that I see that is an opportunity, and we can focus our brain power to invent more things, right? You can develop more creative applications, and you can focus on some other areas, right? Without putting your effort on those simpler tasks that the machine can do for you. So that's my take on that concern. So that's basically, I feel like people really shouldn't worry about machines taking jobs away. Now, another thing that I want to say is, so there's a limitation in terms of using AI to deal with things. For example, if you do a machine learning application, you try to make decisions, and those decisions will be basically based on what type of data, training data that is available to you, right? So in that aspect, there's this I guess new direction saying like fairness of AI, right? So how do you actually make this tool to operate in a way that you want it to be and not biased toward anything. So that is, I think, something that we should be really careful about, just fairness of using these tools, like take care of all these equity issues and those type of things, right? So when human beings make decisions, then there are always concerns, behind those decision makers. But the same thing for AI as well, because lots of decisions that made by that application based on the resources that are available to this application. So that is, sort of like a concern, but I think it's addressable. Yeah.
I think that's related. There's the whole new area of kind of ethics for computer science. And when a program is making a decision, who is going to be responsible when that decision is wrong?
Exactly.
Yeah, I think that there's just a whole new area.
Yeah.
Awesome. Very fantastically said to bring up how AI can have, generalizing struggles and career warnings from Dr. Fern and Dr. Zhao's point about the loss of jobs misconception and how AI shouldn't really be put in that negative light, and even I would think would create opportunities and jobs. So yeah, AI doesn't really shouldn't be put in that negative light for sure. Which leads to my next question, which hopefully we aim to be a relatively quick one. So what are possible career paths for a CS graduate fresh from university?
So I think that there's so many possibilities. You can have the classic, going to become a software developer, game developer, or you can become an IT management, just system management. You can do database management. So there's, of course, data scientists, and you can also, if you have computer security training, you can become a security analyst. Just a variety. There's so many different possibilities. And also the other thing about it, I think it's because many areas require data analysis now. So you can have computer science degree and you can go into many different areas. For example, you can go into work with, like I have students graduate from computer science and go work at Cornell Ornithology Lab to analyze their data, to work with ecologists. And there's a lot of opportunities for cross-cutting, applying what you learn to complete the field that you have not been prepared for it, but you will learn on your job. Related point, it's a great idea to consider double measuring. In this case, if you have a particular passion and computer science, double measure computer science with another area can really just get you jump started way ahead of other people. So I think and it's also many schools actually have that kind of setup for people who are interested in different areas, and very nicely designed curriculum to accommodate that. So yeah, I think that the short answer is really endless opportunities.
Yeah, I totally agree. I also have students who graduated with our degree and then went to a totally different field, like for example, health industry. I had some students went, to like drug design companies, right? Just develop applications for them and analyze data for those scientists, all right? So if you think about it, I think, literally every company will need somebody who knows computer science, who knows how to program, who knows how to analyze data. So that's why there are so many opportunities out there for, a computer science graduate to go into. Now, of course, another path is to, do a graduate degree and get a PhD and be a researcher. So that's always available there. So that's another path. But if you get a job right after undergraduate degree, it's just like Shelley said, endless opportunities out there.
Awesome. There are really so many opportunities and possibilities for a CS graduate to partake for sure. Makes me think that CS is really not a field of just science, but just a way of advancing a particular passion or subset of lifestyles, because really computers will be just part of our life in the future as well. So yeah, no, that perfectly leads into our next question. Which career paths might require advanced degrees like master's or PhD degree?
Yes, professors and or researchers, right? So if you want to get into a research type of position, right? So you see not only academia, but in IT companies, and they also have research center, and they hire research scientists, right, to investigate lots of new emergent topics in their field. So basically, so any type of research heavy positions will require a more advanced degree, because you have like longer time to be trained for that specific area. So that's my answer to this. So like, if you are really interested in like development, or you want to create something right away, that's more, like a engineer type of position. If you want to investigate like a totally, like a novel problem, and you want to put your time in it and then come up with like a novel approach to solve that problem, then that's more like a researching, and you really need to have the time, right, and to learn the more advanced topics in that area. So that will need like a more advanced degree.
Yeah, I totally agree with that. I just want to add that a lot of those degree requirements really fundamentally is about experience. It's about requiring you to have sufficient experience to carry out the type of innovative research or creative thinking, creative problem solving. So if I have seen in our field, some of those big companies actually hiring very fresh, like undergrad students to actually do research as well. So the research jobs have actually becoming more and more commonly accessible for people who has not necessarily a degree, but more importantly, a skill set. And so I think that's the only thing that I want to add.
Awesome. So next I'll ask a question proposed from the audience, actually. What classes should a student take in high school if they want to pursue CS as their major?
So this is kind of tricky. This is kind of tricky because I didn't have an undergraduate degree here. I didn't have a high school education here. So I don't know, Xinhui, do you have any?
I don't know what type of courses are available in high school, but I would think, because my son is in middle school right now, and he has classes like STEM, right, and STEM education and coding, and those like introduction type of courses. If you have those available, that's definitely be helpful. I think one thing that I can think of is, the whatever course that can motivate your computational thinking, right? And because that's the basic element to get into the computer science area. And once you get into a college, then like you can learn all those other things right away, because those courses will be available in your undergraduate phase. So in high school, just to motivate you, think things, like the computational thinking is basically the main thing. Whatever that is related to that, I think will be helpful, whether STEM or coding or a simple programming course. All right, so those are definitely, will be helpful.
Yeah. So I also want to caution about the idea that you have to have a whole bunch of computer science courses if you want to go into study computer science. I think or you have to be a good programmer to have a successful computer science education, successful career in computer science to go into it. I think that's a kind of I don't agree with that. And then we also, so from my point of view in computer science, the most important skill actually is kind of it's abstract thinking. So how can you take an instance of problem and then map it to abstract concepts and come up with a solution that can not just solve the single instance problem, but can solve many instances of similar problems. And so that requires you abstract away from the specific example, specific problem, and start thinking about it in the general term, in the abstract term. So math is definitely, having a good math education, just build logical thinking capability, creative problem solving, critical thinking. All those are going to be very helpful. You have those skill set, even if you don't know how to program, you're going to be all set. You'll be fine.
Yeah, 100%. I agree with that. As a senior, going to be a senior in high school, I feel like I could add on to this question as well. So I feel like, in my opinion, classes and courses can only get you that far in computer science, I'd say. But the real way to really advance your computer science knowledge and is to really just, of course, do it. And just like I remember Dr. Fern, just her first advice for us high schoolers is just do computer science. And that's, you gain the experience, you gain the and you learn through the actual experiencing writing code. And of course, if you don't know how to program, of course, getting classes, going through those courses are definitely going to help you understand how to code. But then once you take those classes, and if you already do know some programming, of course, program more, and with more and more experience, you're really going to get far. And if you don't know how to program, get a basic understanding of programming, just like it doesn't have to be too good, because once you at least have a tiny foundation, you can really build upon that foundation. So that's what I want to add on. Hopefully you're happy with that cool answer. I feel like that can lead into one of my next questions. How much does math play into the role of computer science in general, and maybe tied into AI and machine learning too?
So I will start. I think in general, I don't know if you know, computer science originally usually split out from mathematics. So in many schools, in the old type of schools, you still have computer science is in the mathematics department. So that tells you how much computer science actually is related to math, and especially because the theoretical side of computer science is really deep embedded in math. So I think I would say math is very important. Some areas are more critically so than other. So for example, I think machine learning and AI, when you have really good solid math background, and it makes things so much easier, because we in AI machine learning, a lot of it is about optimization and the mathematical operation behind how do you actually optimize things efficiently? What is the best objective you can formulate that's efficient to optimize and also gives you the solution you want? So a strong math background gives you a lot of leverage to go. And in fact, we actually, especially in machine learning, when we apply, just have students apply, like if you don't have computer science background, but you have very strong math background, we like you for grad school, that is. And other areas, I think computer graphics is also heavily in, like lots of math and very heavy requirement, but different areas. Some areas maybe less so. I think maybe human-computer interaction is not so critical as well. But yeah, it depends on the area. But in general, I would say math is pretty important.
Yes, I agree. So if you look at the curriculum in a computer science department, lots of entry-level computer science courses actually have the prerequisite of a math class, right? Linear algebra, calculus, discrete math. Lots of those math courses, pure math courses, will appear in our curriculum as prerequisite. So that shows how important those knowledge is, like in terms of getting a computer science degree. But like Xiaoli has said, it's not all the areas will heavily rely on that, but having a strong background in math will definitely help you to be more successful in computer science. And AI and machine learning, there's also another aspect of the math, which is statistics, right? So you really have to know a lot about the statistics to be able to, analyze the data in a better way and comprehend the knowledge behind the data. So that's another thing that we really need if you want to get into AI and machine learning.
Awesome. Great answers. I think a great question to lead into that is, does an undergraduate degree from a prestigious school matter, and any general suggestions for school selections?
So I will start by providing my answer. I think so if you are talking about career, like if you are looking for jobs right after school, and the undergraduate, like a prestigious school, will have more kind of national visibility compared to a school that has not as much prestige, and maybe the visibility is more local. And I think that would be kind of the primary differences, like during the recruiting process, you will see big companies flocking to those prestigious schools and heavy recruiting, whereas less prestigious schools, you will see more of a regional presentation of all the companies nearby. And nationally speaking, it will be not as intense. There will be some, but not as intense, and also timeline-wise, maybe a little bit behind those big schools. So that's the major difference in terms of, I don't think, so for graduate school, I don't think that really plays much of a role. As more important thing is your experience during your degree, your grades, the courses that you took, and what are kind of experience that you have. Did you participate? Did you do internship? And did you have good like participate in some research? And all those experiences are going to actually play a more important role than other, whether you graduated from the top school.
Yeah, I agree. I think that the experience matters more than the name of the school. But of course, it's really nice if you get into a top school, right? Absolutely. So that you get a better start. But even if not, I don't think that's the end of the world, right? So you see lots of people who graduated from a so-so university, but be really, really successful later in their career. So I think focusing only on a couple of top schools is not a great idea. So you want to think about what type of experience you want to get in the college, and you want to be around the people that you would like to interact with, right? If you have a passion in certain type of area, then you want to get into a school which is really strong in that area, right? Not only like a general top name, but focusing on the area that you really like. So that's more important from my opinion. And like Xiaoli mentioned, if you really want to get an advanced degree, like a master's or a PhD, then the undergraduate university, which university that you get into, is not that critical, because you can complete your undergraduate degree and do really good research or do some good projects there, and then you apply for other schools in the graduate study, and then you get an opportunity to go to a different university and experience a different environment. So you know, all those opportunities are out there, but don't just focusing on like one or two top schools. That's my suggestion.
Cool. Leah asks from the audience, any liberal arts classes you will recommend rather than science and math?
Writing. I think it's communication. Anything that can actually allow you to communicate more effectively is great. I think even computer science, you need to be effective in communicating. So I think that's a general kind of a skill that you should foster and develop as much as you can.
Yeah, totally. That's even more important if you work in an interdisciplinary area, right? So you have to talk to different type of people who have a diverse background, right? So knowing how to effectively communicate your ideas and describe your solution to those different types of people is really critical.
I think it will be the more like technical writing, maybe less creative writing, just to kind of specify it a little bit more detail.
Awesome. Okay, we're running close on time, so I feel like I'll answer. I mean, no, I'll ask this question. So of course we've been talking about a lot about computer science, how we can really get into it, how what AI is, AI in general, and of course just how to guide us into computer science, I would say. But of course, while we're in the computer science field and everything, I feel it's important to find people that are like alike you, and build yourself a community in the computer science world. So my next question is, how do I find a community in the computer science world, in my region or worldwide? Because I feel a community is, you know, very important. So yeah.
I can comment on that. I think there are two ways that you form community. One way is you form a community locally, like you're doing right now, right? So I think this is a great thing that you're doing, bring people together, who, you know, those people who have similar interests, and having events like this and learn together. That's a great way to form a community by yourself. Another way is to join a community. If you can find a community which has similar interests, for example, for computer science, right? I know, Kyle, you like video games, you like to write lots of code, and you can easily find a community in the open source, you know, like a open source website, for example, GitHub, right? So if you figure out an open source project which you're really interested in, you can contribute to that project. And there are discussion forums, right? You can talk to people that way virtually. And when you get questions, you ask in those online forums like a Stack Overflow and like a technical online forum. That's a place where you can actually meet people like. And once you get into a university, then you have more people around you, right? You have classmates, you have people from other colleges, people in other disciplinaries, and you basically talk to them and then find similar interests and then form a community around you.
Yeah, I think a few things to add would be, so if you're in school, usually there's the student bodies that generally, so for example, we have AI club, student clubs that focus on AI, focus on machine learning, and Those are awesome. And there's also national ones that you can go to. So as a student, sometimes you can participate in regional or national conferences. So for computer science, there's not necessarily just academic research conferences. There are things that are more broader, like Grace Hopper for broadening participation. So underrepresented students from underrepresented groups are encouraged to go to this type of meetings to find their peers and have a broader set of kind of peer group that they can communicate and just kind of grow together. And in my career, I found the community that I really hold on to are the conference buddies. When we go to conference and we see each other once a year and then just talk about exciting research and what everybody's up to. So that's a kind of, if you're further along in your career, those are great opportunities to build a peer network to actually grow together.
Awesome. We're over time. So Dr. Fern, Dr. Zhao, any last encouraging words for students who want to pursue a computer science degree or in computer science, or are unsure about if they want to dive into the depths of computer science?
My last advice would be, I want to echo what I said at the beginning. Find your passion inside yourself, not from any external sources, because that will actually motivate you to do what you really like, and that will give you the power to overcome whatever challenges that you may have in the past. Because computer science, it's promising, but on the way you might have difficulties, right? So, and if your energy comes from outside, then it will be really, really challenging for you to move forward. But just ask yourself what you really want to do in your career and find the passion inside yourself. I think that will help you to be more successful in the future.
On that note, if you are one of those who don't know what your passion is and find it extremely hard to actually identify exactly what you're passionate about, as long as you have a curious mind, if you are interested in learning, and I think computer science would be a great area to kind of, because it's so widely useful. So it's not going to be limiting that if you go into computer science, you're locked in your career, what to do. It's like a key that can open many, many doors. And so if you don't know exactly what your passion is, you don't feel the growing passion, say, hey, I want to do computer science yet, is still something that I think it's worth consider as one of the essential skills that you're going to build to go into your career, whichever it might be, your future passion.
Yes, for sure. I guess I have a final word for anyone who might be unsure about what they want to do in their future. Because so if you're unsure about what your passion is, my opinion on this is really, if you're young like me, take many classes, stay hungry for knowledge, stay curious, just like Dr. Fern said, stay curious for sure, stay hungry. And soon enough, you'll strike something that resonates with you, I would say, like a field that resonates with you. And it's hard to describe, but until you resonate with that class, then you will find you'll know what I mean. It's a feeling that you just know it's for you. It's the one field for you. It's just like it's just like relationships, I guess. You don't know who the right one is until you know and they come in your life, right? So keep exploring, and of course, if you don't know what you want, what passion, of course, stay hungry for knowledge, stay curious, and eventually, when the right one comes, it will come. Anyways, all right. Thanks everyone for joining us today in this panel discussion with Dr. Fern and Dr. Zhao, and of course, thanks to them for making this possible. And thanks for them for, taking time out of their busy lives to join us today and talk about computer science and any questions you guys have. With that said, hope you guys enjoyed the discussion. And of course, I learned a lot from these two professors, and I hope you guys did too. Not even just about computer science, but just like your life, what you want to do, and just passions. Just it's this, you can take this to more, like you can take this outside of computer science. You can take this to just apply to your future, whatever your future is. Doesn't have to be computer science. Anyways, thanks everyone, and thanks
Good luck to you all.
Dr. Zhao.
Yeah, good luck. Thanks, Kyle, for organizing this. This is great.
I hope to see some of you at Oregon State.
Likewise, come to us as well.
Well, that's great call there. Thank you, guys.
Bye.
Bye.
Bye everyone.
Bye.